Section 1.3, measuring and constructing angles. So what we're going to do is we're going to zero in on these certain objects called angles, measuring, constructing, talking about them, making sure we're all on the same page, developing a common language. So an angle is formed by two of those rays with a common endpoint. So a ray has an endpoint, then it goes off in a direction, and then another ray has the same endpoint, goes off in a different direction. With that V, you create that angle. Now the common endpoint is called the vertex. Plural is vertices. We'll get into vertices later. Now you can name an angle by several different ways, okay? And I have this diagram here, and there's really two sides to an angle. There's all of the points that are between the sides. We call that the interior of the angle. So if you were to take a point and bounce it off a side, it would just keep bouncing off the sides in between there. All right? If you are outside the angle, you take a point, you bounce it off there, boom, goes away and never comes back. That's in the exterior of the angle. And there are a number of ways that we can name this angle right here. So angle SRT. Now that's one way you can do it. You kind of just trace along the angle. So angle, that symbol, you kind of come down and then horizontal over. SRT. But maybe you're a bottom to top kind of person, and you're like, well, no, I saw TRS. Well, you can do that also. Now, there's also this common endpoint of the two rays called the vertex. You can also name it that point, just angle R. There's no other angles around here that would be confusing. R is just the vertex of that single angle. There's also this number in here, and that's really my favorite way to name angles, is just with the number. Angle 1. So all of those four different ways are different ways to talk about that angle. So you have some options here. I like the numbers, personally. So if we go down here, kind of giving it away here, name all three angles in that diagram. There is one very wrong way you could do this, is if you said angle A. Because here's a problem with that. There's three angles in this diagram. All three of those angles have a common vertex of point A. So if you say angle A, which one are you talking about? It's a little ambiguous. And I am all about, my favorite word here, specificity. Just say that. Specificity. Just feels good to say. All right? But you have to be specific and intentional with your language. So this angle to the left, angle BAC. This angle here to the right, angle CAD. And this angle, the overall, angle bad. Now here's the thing, I really like numbers. I like numbering the angles, because then I don't have to do the whole 3 points thing, because that can get a little overwhelming at times. So I can just go and put some numbers in there. I can annotate this diagram. So angle 1 and angle 2. Those are options for you as well. Now you take a circle and you slice it into 360 slices. All right? These are like the most unsatisfying slices of pie you will ever have. You take that pie and 360 slices all the way around, okay? So give me like 100 of those slices and I'll be happy. If you just give me one of them, I'm going to leave. So if you slice the circle into 360 pieces, 360 slices, each of those represents 1 degree. So there are 360 degrees in a circle, and that is usually how we measure angles. We measure them with degrees. That is our unit of measure. Why do we use degrees? Because we said so. It's the protractor postulate. It essentially says that angles can be measured. There's a standard unit of measure. All right? And it's a postulate. You have to accept it. If you don't accept it, you can't measure angles. You can't have fun with the rest of us. Okay? So, the protractor postulate really acts like the ruler postulate. It says we can measure stuff. And there are different types of angles. There's an acute angle, measures between 0 and 90 degrees. There's a right angle, exactly 90. Obtuse, between 90 and 180. And a straight angle, otherwise known as a line, is exactly 180 degrees. Now you can make these greater. You can have an angle greater than 180 degrees. We call that a reflex angle. So just looking at a protractor, making sure you know how to measure this, there are two different measures here. All right, so depending on where your angle starts, if you're measuring over here, you're going to use the acute measures because it's an acute angle. But if you cross that 90 and move over, now you're using the obtuse measures. So pause the video, take a moment to find all of these measures. So the measure M of angle BOA, the measure M of angle DOB, the measure angle EOC. Take a moment to look at those measures, check my completed notes before moving on. So if we can measure angles, that means that some angles may have the same measure as each other. We call those, you could probably predict this, congruent angles, angles that have the same measure. So if the measure, that's our notation, the measure of angle ABC equals the measure of angle DEF, then those two angles are congruent to each other. And we use arc marks, just a little right in that angle, tucked up next to the vertex. Now if you have two other angles that are congruent to each other, but they are not congruent to the first pair, you just kind of double up and do two arc marks to say, okay, here's a pair of congruent angles, here's a pair of congruent angles, but they are different from each other. So because we can measure angles, we can quantify them, that means we can add them up. So the angle addition postulate, much like the segment addition postulate. S is in the interior of an overall angle, angle PQR. So wherever S divides that angle, the two smaller pieces add up to the whole that we started with, angle addition postulate. So we have here the measure of angle DEG is equal to 115. The measure of angle DEF is 48. Find the measure of FEG. So we have an obtuse angle, DEG, and then we have this point F, kind of in the interior. I'm going to move that over here. Try and keep this drawing as much to scale as possible. So we know that DEG is 115 degrees. We know that DEF is 48 degrees. So find the measure of angle FEG. So because of this diagram, we can use the angle addition postulate. The measure of angle DEF plus the measure of angle FEG equals the measure of angle DEG. So now let's substitute in what we know. We know that 48 degrees is DEF. We are trying to find the measure of angle FEG. And we know that angle DEG is 115. So when we subtract from both sides, I want to make sure I get this right. Take away 40, you get 75, another 8, and 15 minus 8 always gets the better of me. I'm going to go with 67. Now, personally, I think this is a little involved for this problem. But what I wanted to show you is kind of a good setup that you can do. With a diagram, your reasoning, really the formula that you're using. You know, in math you get formulas, you write them down, you use them. Well, this postulate is our formula. It's telling us what to do. And then writing that equation is solving. Here's the big difference from Algebra 1 to geometry. Okay, in Algebra 1 we give you a lot of equations and you solve them. In geometry, you're going to have to write the equation that you need to solve. So you need to know what equation to write and why you're allowed to write it. If you can divide angles up, it's entirely possible that you cut it right in half. An angle bisector is a ray that divides an angle into two congruent angles. So ray JK, ray JK, bisects angle LJM. Therefore, thus, the measure of angle LJK would be equal to the measure of angle MJK. Those two halves are going to be equal to each other. So with example 4, we know that KM is bisecting this angle. So we know right off the bat that these two halves are congruent to each other. Use the segment addition postulate to write an equation, then solve that equation. Make sure you are answering the question that is being asked. And you can check your solution with my completed notes online.